Okay, so we're going to start section 14.4, sum and difference identities. And what we're going to do is we're going to work with angle values that have a combination of our special angles, our 30, 60, 90s, and 45, 45, 90s, but by themselves are not special angles. So, for example, if I asked for the sine of 105 degrees, that is not a special angle, but if I split it into a 60 and a 45, I can get an exact value and work with that. So how do we do that? And that's what this section is about. And so these are the actual formulas that we're going to use, and you need to know these by memory. And I'm going to write them a little bit different when we start doing some example problems and just basically a combination. So you're going to notice here we have 2 for sine, and there's a pattern to them. So what I did is I said, okay, well, if I had sine of 105 degrees, well, I could split that into a 60 plus a 45, and so this is how we would work with it. So I'd have sine is 60, so angle A is 60 degrees, and angle B is 45 degrees. And so cosine of angle B plus cosine of angle A plus sine of angle B. And so now I would evaluate each one of these individually by using this formula, and it would give me the exact value. Okay? And so we can also subtract angles, and then if I'm finding cosine, right, we have a slightly different formula for cosine. And so notice with sine, we alternate. It goes sine, cosine, cosine, sine. And for the same, and when we're adding for sine, we're adding in the formula. When we're subtracting 2 angles for sine, we're also subtracting in formula. Cosine is slightly different. When we're adding 2 angles, we're going to subtract the terms that we get when we use the formula, and it's always cosine together and sine together. So these are little patterns that you can use to help yourself kind of remember the formulas. So now let's go ahead and begin with an example. And so we've already got it split for you, so we're going to find the exact value of sine of 135 degrees. So I'm going to write the formula slightly different because this is how you're going to see it in most texts. And I'm going to we'll use A, and it'll be plus or minus B. So are we going to use addition or subtraction? And so that would equal sine of angle A times cosine of angle B plus or minus cosine of angle A sine of angle B. Okay? So we're adding our angles. So that means the way that this is both formulas together written as one. So rather than writing 2 separate formulas, I've written one with the plus or minus. So because the plus is on top here, this is what I'm going to use. They're in conjunction. They're both on top, so I'm going to use both of these. So then that means sine of angle A is the first one, 135 degrees, plus, let me erase that, the 30 degrees. And then I'm going to expand it, so angle A is 135 degrees, so I plug that in. And then cosine of 30 degrees, plus, because it's a plus up here, cosine of 135 degrees, sine of 30 degrees. And really what we're evaluating is sine of 165 degrees. Okay? And so now we're going to go ahead and evaluate this, and these are our common unit circle values. And so I'm going to write a little trick down on the left-hand side. When we have a 30-degree reference angle, if we were going to go through the unit circle, I'd have these points. 45 degrees is going to be root 2 over 2, root 2 over 2. And these are all obtained from working with our 30, 60, 90s and 45, 45, 90s. And so what I have here is I know cosine is going to be our x values. And I know sine is going to be our y values, okay? Because cosine is x and sine is y. So then I look at this and I say, okay, well, what's my reference angle? It's 135. That's a 45-degree reference angle, so I know that guy is going to be root 2 over 2. So I write this piece down right here that this is just like a little tool that I can use, and I'm going to write it down when I take a test or a quiz to help remember what my values are. The only other thing that I need to know, is where are these guys positive or negative? So I got to still remember the all students take calculus. So that means sine of 135, 45-degree reference angle. I go to my little table here. I go sine is y, root 2 over 2. Sine's positive in the second quadrant. So this guy is root 2 over 2. Cosine of 30. So I go to this. Here's my cosine. I find 30 degrees. That's root 3 over 2. Cosine, first 30 degrees is in the first quadrant. They're all positive. Boom, I put in the root 3 over 2. Plus cosine of 135, that's a 45-degree reference angle. Cosine's root 2 over 2, but cosine is negative in the second quadrant. So I'm going to put in a negative root 2 over 2. And then the last one is sine of 30 degrees. Okay, sine of 30. I go to my 30. Sine is 1/2, and it's the first quadrant, so it's positive. So boom, I put the 1/2, and now I multiply through. Fractions, so I multiply across. So root 2 times root 3 is root 6, and 2 times 2 is 4. Negative root 2, so I'm going to erase the plus that I just wrote down there, times 1 is a negative root 2 over 4. And because they have the same denominator, I can write the tops together. And a root 6 and a root 2 aren't the same, so when we're dealing with addition or subtraction, I can't combine them. And so if you took sine of 165 on your calculator, and then you took this value and got the decimal value, they would equal each other. So sine of 165 is equal to root 6 minus root 2 all over 4. So this is something I'm going to keep on drawing on these examples so you get practice with this, and this is going to be a huge help because then you can quickly get these values that you need. The other thing that I want to mention is that when you look at this piece right here, I know that the root 3 over 2 is the first term because 30 is a 3, so it starts with the root 3. The other one's got to be 1/2. The 45s, it's a 1 root 2, so you know it's going to be the root 2 over root 2. And 60 and 30 are just flip-flopped because the sides of the triangle change position. So that means I just take what I got for the 30 and switch the coordinates. Okay, so once again, I'll write this down on future presentations so you get in the habit of using this. And this is how we would find trig values for not so nice angles, but we can find two nice angles that make up the 165. Okay?